Hey guys, so today is going to be a little bit different. We're going to start proofs. And in order to make them a little bit easier, I made this proof foldable. This is the digital version. We also do have a paper version we could print for you if you need. But this digital version will be made available to everyone in Schoology as well as on your notes page. This link right here will take you to make a copy of that foldable, or to where it'll play in line like this as another tab in your link. But just like I have it like this with Schoology, if you want to use it whenever you're doing notes or something like that, or maybe even if you're taking your quiz, I would pull it out as a second um, tab, kind of like what I got going on, where I have the notes on the left and then the tab on the right. That way you don't get locked out of a quiz or a test that you're taking. But the first thing that we want to do is go over just the proof basics on this foldable. So I'm going to enlarge it so that we can just go over that because that's all we want to focus on first. So we want to do the proof basics part of the foldable. So it looks like this, and there are three things that you automatically know immediately anytime you do a proof. They will always be the very first things that you write for both statement and reason, and then it will be the very last statement you write. It may not necessarily be the third, but it's going to be the very last thing that you write. And so they are these things. The given statement will always go as your very first statement every single time. That's not going to change. The word given itself will be the reason for that given statement. And then the prove statement will be the very last thing that you know. The reason for your prove statement will never, ever, ever be prove. Do not write that. That's not what goes in the reason under 3. It's not the word prove. It will be a reason. In this proof, it's actually the definition of congruence, I believe. We'll find out for sure in a minute. But it will never, ever, ever be the word prove. So don't put that. I know that because the given statement, it says given, that you want to write prove for the prove statement, but it does not work that way. Don't do it. Then there are 3 ways to write proofs. One way is a flowchart proof. It is the definition of congruence. That's what should go there. This is called a flowchart proof, and you just write it with connecting boxes. This is not something that we will be doing in a high school setting. I did have to do it a little bit in college, but of course I'm a math major, so you may not have to do, you may not ever see them again. Paragraph proofs, this is definitely how they do almost all proofs in college. So if you do happen to want to be a math major for some reason, you will see them again, but otherwise you probably won't. And both of these proofs these are the same proofs. They're just written 2 different ways. The way we will write proofs is called a 2-column proof, where you'll have a statement column and a reason column, and you'll fill it out all the way down. So like I said right here, that will never, ever, ever be the word prove. It's going to be a property that you're going to learn in this proof foldable. But that, do not ever write proof there. All right, so we went through the whole proof basics part, the whole proof basics tab of this foldable. Now we're going to focus on the algebra properties tab. You can always make these bigger on your computer if you want to, but we're going to use them right now in order to work through our notes. And this is kind of helpful while you work through any of the proofs that we're going to do here in a minute. But right now we're just going to list all the properties, and you can refer to the proof foldable in order to see what the answers are. So the first one, it says for every number A, then A will equal A. So because it's the exact same thing, it's like a reflection in a mirror, we use the reflexive property. I can't actually draw on, well, I guess I could draw. I could point. Oh, no, I can't. It's not a real projection. Hold on. In teacher mode, we're given a red pointer, but I can use this. But it's the reflexive property. It's any time that it looks like itself. So sometimes you might see it in a proof that looks like this, that the measure of angle ABC is congruent to the measure of angle ABC. If it is the exact same thing, it's the reflexive property. Just like in the mirror, I mean, granted, you really get a mirror image, but it's still the exact same thing staring back at you. So we're going to just write the abbreviation because we're lazy in geometry and don't really like to write out words completely, especially when we're doing proofs. So that's the reflexive, got it right the third time, reflexive property of equality. The next one, for all numbers A and B, A is equal to B, then B is equal to A. So it flip-flops. That is the symmetric property. The symmetric property means that it flip-flops. And they're all the property of equality. Next, it says that if A equals B and B equals C, then A equals C. You remember whenever we did this with words in the previous unit, where it's hypothesis conclusion, then that conclusion is made the next hypothesis to make a different conclusion. And then you take out the things that are the same and what is in the middle is left. We do that. That's actually a logic property too that we're going to use whenever we're doing proofs. So we take out the part that repeats and write what's left, which is A equals C. And that is, whenever we're doing proofs, called the transitive property of equality. The next one is like when you're doing algebra. So over here, you can kind of see what that might look like. In order to move this -4 away, you would add 4 to both sides, and then this is what you would end up getting. So because you would add 4 to both sides to get to the next answer, that's called the addition property of equality. And in this one, of course, you are subtracting on both sides. So that's like this one. In order to move that +4 over to the other side, you would have to subtract 4 from both sides in order to get this answer. So since you would, subtract 4, there we go, then that is the subtraction property of equality. And then on this one, they are multiplying both sides by C. So you can see that here. In order to get that 2 out of the denominator, you would multiply both sides by 2. So that is the multiplication property of equality. And then we're looking at something like this, where you have two things you have to combine. So in here, we need to combine these two A's together to get that to here. So sometime in a real world situation, we would call it combining like terms. But in proofs, you usually say simplify. Plus, it's less words than combining like terms, and we're lazy when we write proofs. The next one is they're dividing by C on both sides, so that would look like this in a real proof where you would need to divide both sides by 2 to get that away from the X. So this is the division property of equality. Oh no, I wrote a bunch of ones. I have to hold my computer like a real computer so I can still use my keyboard, unfortunately, because I need to be able to move my mouse, and I can't do that when I make it a tablet. So this one, too far. It takes this A here and puts it over into the next ones, which is the distributive property of equality. You can see that done here. So what I mean is we take this A and distribute it to both sides, which gives you this part of it. So it is the distributive property of equality. And then the last one is, what happens is they say that A equals D. and then there's an A here. So they just replace it. That's a mistake. I will fix that before y'all get to it. This should be a B, and this should be a D. So what happens is the D gets replaced by that A. It'll be fixed on your notes, so it will say D plus B for y'all. But what happens is that A just gets substituted with the D, and you normally see that with numbers. So like over here, where we substitute a 5 in, because we know that x equals 5, we put 5 in for x, and then we see that it is 7. So that's the substitution property of equality. Teachers make mistakes too. It happens. All right, so this one goes from 1 to 2, and then this one goes from 2 to 1. So it flip-flops is what happens. So remember, the flip-flop is over here. See, it originally was this way around, then it flip-flops. That's called the symmetric property of equality. So the easiest way to use this proof foldable is look over here in the examples and try to find one that kind of matches this, at least looks similar. Recognize what's happening and then find the example that's doing the same thing, and then you can look at what the name is and come up with it. The next one has AC equals BD, then BD equals EG. You take those out, and AC equals EG. So over here, if you don't remember what that's called, here's my example. You take these two out, and then ABC is equal to GEH. That is called the transitive property of equality. The next one is a reflection of itself. So remember, that is the reflexive property of equality. And then on this one, all of a sudden you are multiplying by 1/3. So if you are multiplying, that is the multiplication property of equality. And then here, what happened is they distributed. So that is the distributive property of equality. So that's kind of how we're going to use our algebra foldable as we are doing our proofs. So now we're actually going to work on some algebraic proofs, but first let's understand what they are. It shows the logical argument behind an algebraic solution. There are steps you can always follow when writing an algebraic proof. So the first step would be to write a step-by-step solution of the linear equation. Just like you were solving it in algebra, write it all out step by step. When you do that, you want to make sure that you place the equations in the correct order. Don't do them out of order. And sometimes in our proofs, like on number 7, we give you reasons. So just make sure that when you're working it, that your steps match with those reasons. So that's what that means. Place the given equations in the correct order. And then the last one is you justify each step by using properties of real numbers. In other words, the orange flap of the foldable. All right, so we're going to work some algebraic proofs. In this one, the work is already done for you. These are the steps you would do when solving this proof. And then we have to fill in the reasons. Remember, I told you one of the number one things you know automatically for all proofs is the first statement, the first reason, and the last statement. Unfortunately, there's only one of those things for you to fill in, but you always know those things. And the word given will always go in step number 1 every single time. Well, then what happens over here? What's happening from here to here? Well, they're dividing dividing both sides by 5. That's what's happening from one step to the next. So which one of these properties talks about dividing? Well, that would be this one. And that's the division property of equality. Then what happens from here to here? Well, they actually do the dividing. So 5 divided by 1 and 20 divided by 5. So whenever you are just simplifying something up, you are using the simplify property. So this is simplify. And later on, these two will actually be combined and you won't use the word simplify. You would not do this part at all. And you would just write 3. So this really should only be a 2-step proof. But in the beginning, we want y'all to show all the steps so that you understand why it's the division property. Because sometimes when you just see from here to here, you see that that 5 is multiplying and we get the multiplication property, which it's not. It's the division one because that's what they're doing to move to the next step. It's not what you're looking at. It's what is being done to get there. That's always what you write. So make sure you're paying attention to that. And that's why we start off like this, where we write every single step. But eventually, this part won't be here at all. This will be up here and you'll be done. So that part wouldn't be there either. And you'll see that whenever we move on in later proofs. In these notes, we're going to do it every single time. But in later practices and things, you'll see those things combined. And that's okay. It just means that you're going to leave out the simplify part and just write the division property of equality. So in number 7 now, they have given you all the reasons and you have to write all the steps. But remember, we already know this thing, and this thing for all proofs always. So this will be 2x plus 4 is equal to 10. And this will be x is equal to 3. Every single time, this will be your... Here, I'll do it with different highlights so that we understand. This will be your proof statement. This will be the word given. And this will be that proof statement. It will never, ever, ever have the prove word there. Ever. Don't do that. So make sure that's number 1 thing. You never use that word prove. That doesn't happen. If it helps, cross it out so that you remember not to use it. You use all the other stuff, but not that word prove. All right, so then we basically solve our equation from here. The next thing we would do is subtract 4 from both sides, which is what that next reason is. And this is how we normally would write it in algebra. But whenever we're writing it out in proofs, we write it out all in a line. So instead of doing it underneath, we write it in a line. Then we're going to simplify. In other words, we're going to combine like terms. So those will combine and give me 0. These will combine to give me 6, which gives me 2x equals 6. Then the next thing we would normally do is divide, and we would do it like this. But instead, we're going to write it below all in one line. We're going to rewrite it again, but with that dividing there. Then, of course, you would simplify, which just means you would do the actual dividing. And that's the end of that proof. So again, this guy always goes here. This guy always goes here. This guy always goes here. And that guy goes nowhere. So fill in what we don't have, which is the 4 times 2x plus 3 equals 52. And then what happened from here to here? Well, that 4 got distributed. So which property talks about distributing? It's right here. Distributive property of equality. Then it says subtraction property of equality. So normally you would do this, right? But we're going to write it all in a line rather than underneath. So 8x plus 12 minus 12 equals 52 minus 12. And then to get from here to here, they actually did the subtracting, which is just simplify or combine like terms. But anytime you combine like terms, it's simplify. And that is even here in the definition. Usually used when combining like terms. That's when you simplify. All right, then it says the division property, which means that you rewrite it with the dividing there. And then to get from here to here, you do the actual dividing, which is simplify. And again, later, you won't do step 5 at all. You'll just do step 6, and your reason will be what the arrows are. You won't use that word simplify near as much anymore because you're not going to need to. You're just going to skip that step. So just like whenever you get really comfortable doing algebra, in proofs, we're going to leave those parts out too. All right, I made a mistake on the key of this one. Your note should be correct, but instead of reprinting them on here, I just crossed it out and wrote simplify. So this guy goes here. This guy goes here. And this one goes here. And we do not use this at all. So rewrite it. Negative 2 plus 9x plus 5 is equal to 5x minus 1. And then, of course, you write the x equals negative 2 down here. So what happened from here to here? Well, this got distributed. So that property is the distributive property of equality. Then it says simplify, which almost always means combine like terms, which are, oops, there and there. So negative 2 plus 5 is plus 3. Then what is happening from here to here? Well, they put in a minus 5x on both sides. So they're subtracting on both sides. If you are subtracting on both sides, it's the subtraction property of equality. Then it says simplify, which almost always means combine like terms. So we combine these guys to be 4x plus 3. And then these end up giving me 0, so I'm just left with negative 5. And then what happens from here to here? I'm subtracting 3 on both sides. So subtracting again, which is the subtraction property of equality. Then simplify, which means combine like terms. So this will give me 0 and cancel. I'm just left with 4x. This gives me negative 8. Then what do I do from here to here? Well, I'm dividing by 4. So division property of equality. We're done with that one. Now we're going to do our own from scratch. So we have our statements and reasons. And remember, this guy will go here. This guy will go here. But this one will be our last statement, but we don't know how many statements we have when it's set up like this. But just remember that that is your goal. That's where you're going to need to go. We can fill in the rest of it. So this is negative 2 times x plus 5 divided by 3 is equal to negative 2. My reason is given. Oh, and that was our first step. So what will we naturally do next? Well, we don't like denominators ever in algebra. So in order to get that 3 out of the denominator, we would multiply both sides by 3. So then, because we multiplied, it would be the multiplication property of equality. The next step would be to simplify. So in other words, these cancel. We're just left with 2x plus 5 is equal to negative 2 times 3 is negative 6. So we just simplified. Or combined like terms, same kind of thing. 4. The next thing we would naturally do in this is distribute to get negative 2x minus 10 is equal to negative 6. So which property talks about distributing? The distributive property of equality. The next thing we would naturally do is add 10 to both sides, but we write it all in a line now. So negative 2x minus 10 plus 10 equals negative 6 plus 10. And since we added on both sides, that is the addition property of equality. Then we need to simplify or combine like terms. So 2x is all, negative 2x is all that's left on the left. Negative 6 plus 10 gives me 4. That's simplify. Then we divide by 2 on both sides, but we rewrite it again like this. And since we divided, it's the division property of equality. And then the last thing we would do is simplify that. So actually do, we divide by negative 2. Sorry. We simplify it to get our final answer, which should be x is equal to negative 2. Let's make sure it is. X is equal to 4 divided by negative 2 is negative 2. And that reason that we did that is not proof. From here to here, what did you do? We simplified. So that's how you would do that. But also, you don't necessarily have to do all of this together, do this together, or do these together. You can combine them. So that could have been a shorter proof. So this next one, I will do it the shorter way, meaning that we're going to skip those steps and just write what the next answer is. So instead of writing the work, like this is work, this is work, and this is work. You leave those purple parts out, and then you won't have these simplifies there. So that's the way that will work whenever we redo it again. Well, we're not going to redo that one. We're going to just do this one. So statements and reasons. Remember the first one. Oops, I highlighted too much. That goes here. And that goes here. And then this will go somewhere, but we don't know where yet. So it's x over 3 plus 2x over 4 equals 10. And the reason is given. Now, in order to skip steps, sometimes whenever you're just learning, it would help over here for you to work the actual problem. So the next thing we would do is multiply everything by 12 to get common denominators and to get the denominators to go away. Because the least common multiple of 3 and 4 would be 12. So we're going to multiply everything by 12. So it would look like this. But instead of writing that part in our proof, we're just going to write its answer. So we would end up with 12 divided by 3 is 4x plus 12 times 2 is 24, divided by 4 is 6x, is equal to 120. And the reason is because we multiplied these 12s. So our reason is the multiplication property of equality. So the next thing that we would normally do is combine like terms. So what would the answer be of both of those two combined? Which is 10x is equal to 120. And combining like terms, remember, we just use the word simplify. Then the next thing we would normally do at this point is divide both sides by 10, but we're just going to write the answer, which is x is equal to 12. And of course, that's what it's supposed to be. And the reason is because we divided. So the division property of equality. So this is the part you're supposed to do in your head. I was just showing you my thinking visually so that you would know how I did each of those steps. But this is normally how you're going to do properties in our class. You very rarely, well, in any of our classes, you very rarely will ever list each individual step that you do. That's just not typical for most proofs. You're going to skip those steps and write it like we did number 11. And now we're done with the first part of learning proofs.